Well, I'm at home doing a little bit of research. I'm just going through my textbooks from my radio technician's career and my radio engineering career. Here's just a small sample. Here's Electronic and Radio Engineering by Terman. Radio Engineering Handbook, Henley. That one's published in 1950. Fundamental of Electronic Circuits. Digital Transmission Systems. What have we got here? Telecommunications by Fraser. Telecommunication Transmission Handbook, 2nd edition. Radio Amateurs Handbook, 1956. We've even got a Royal Signals Handbook of Line Communication, Volume 2. Yeah, this one here is printed in, here we go, 1947. It might not show up, it might not focus on that. And a few books that are appropriate to the subject in question. Communication Electronic Circuits by J.J. DeFrance. There's a book here on antennas by Connor. And what have we got here? Services Textbook of Radio, Transmission and Propagation. That's a Services Handbook. That was probably published before I was born too. Radio Systems for Technicians by D.C. Green. Now the whole purpose of dragging these books out is I'm just doing a little bit of research on quarter wave whips. I believed that a quarter wave isn't resonant, and by doing this research I found that to be true. Quarter wave length is not a resonant length at all. A quarter wave whip works by virtue of the fact that it's mounted on top of a ground plane, and it uses that ground plane as a radio reflective surface, and the image, the quarter wave, which is the image, makes the aerial appear as though it's a half wave. So you've got a half wave above and you've got a quarter wave above and a quarter wave below. But the most important thing is that there's current flowing in the ground plane. So the ground plane must be conductive. If the ground plane isn't there at all because it's fresh air, then it neither provides a reflection nor provides any conduction. Therefore the aerial won't work properly. But anyway, we might read some of the sequences out of these books and splice it into a video. Here's a perfect example of a quarter wave whip mounted in an inadequate situation, or it's an inappropriate aerial for the situation. What we have here is we have a quarter wave whip. In this location we have an adequate ground plane provided by the bonnet, and out here we have fresh air. So this aerial won't radiate properly because it's not got a counterpoise right round here. So in this situation I would say wrong choice of aerial, and I'm being polite. Now the machine actually has a fairly substantial cab which is part of its rollover protection, and unfortunately it doesn't have any spot really where you can mount a bracket or pretty much do anything. So on this machine we've elected to use a magnetic base. Now with a magnetic base on a large metal surface like this, you can get away with a quarter wave whip. It's a perfect situation for a quarter wave whip because this metal surface here provides you with your ground plane. The ground plane is your radio reflective surface, and it's pretty much ideal. Now how much ground plane do you actually need? It's a good question. as a rough rule of thumb, because this is a reflective surface, what we do is we consider the active component of this antenna to be the radius for the ground plane. If you've got that much ground plane, then the aerial will work fine. If you have no ground plane at all, or no flat metal surface, or half of the surface is missing, then the aerial won't radiate properly, won't work properly. So as a rough rule of thumb for ground plane aerials, use the active element, this piece of it, as the radius for the diameter of the circle that you need.